Welcome everybody to this talk about the new caching strategy in Liferay. To start with, I would like to have a look on the common caching problems and headaches that every organization delivering digital content faces. The first one happens when you don't cache anything. So if you don't cache your JS and CSS files, at the end of the day, the user is requesting all the files every time they are requesting a new page or reloading. So that, as you can imagine, leads to poor performance. And the second problem is when you do exactly the opposite. When you cache everything, it's very fast, but you are in the risk that the users are seeing some stale file, CSS or JS, and they can be watching old experience or any old business logic that you don't want to show. And the third problem is when you use another technique, which is using e-tag and revalidation. That's nice because you revalidate to see if you need the file or not every time, but that can lead to a very high CPU usage and latency. And also, apart from the common problems, in Liferay we have some particularities because we have these two kinds of files, the tokenized CSS and also the JavaScript files that has labels with languages. And in these files, they are processed in runtime. So when you are requesting, depending on a parameter or depending on server context, we are providing different content depending on the server context. So we can not cache that kind of files. So that's a problem, and that is also taken in the strategy. This is useful for some goals, but has to be dealt with. So every talk about caching, I think, has to show this famous quote from Phil Carton, saying that there are only two hard things in computer science: caching validation and naming things. Next slide. Sorry. Oh, I guess he was right. Caching validation is a problem. So let's go with the caching strategy. So we have enhanced cache boosting, which means that from now on, all the files, in this case the JavaScript, that are in the repo, here we are seeing this frontend.js web/index. On build time, the name is hash, so the name that will be in the jar file is with this cafe hash. So then when the browser is requesting the file, the browser is using an import using the canonical name, the index.js, but then the import maps is mapping to the new name. So it's the way that we know that we are always mapping the name of the last version of the file. And for CSS, we cannot rely on import maps. So apart from hashing the name of the file, we have also worked in hash also all the reference in the link tags or all the reference that we are using inside DXP to reference the CSS files. So when the hash changes, so imagine that we have this file in the version, in the release queue, and this has this cafe hash that we see there. It changes when the content changes. So if this file is changed in an update, the build is taking all the content of the file and stringifying somehow and hashing the content. So we know that the last version of the file is always going to be delivered. So imagine this situation. We have a new deployment, a hotfix or example, and we have been working on the multi-select file. So all the white files are not touched, so the hash remains. But for the last one, which is the one with the bug or whatever, as the content has changed, the hash also changes, and then we are being sure that we are delivering a new file. So how this works? For the first visit of a user, The browser is calling the file. The DXP server is returning the 200 OK with the full file. Then the cache control is immutable, and the max says for a year. Why a year? Because you have to put a number. So a year was infinite enough in software, and we decided to put a year. And in the following visits, when you request the file, you don't hit the network. And you know that you are in the last version of the file because the import maps knows the last version. So even if you are facing a CDN between your browser and the DXP server, you are not hitting the CDN as well. So what happens if we don't know the name of the hash file? This is a fallback. This shouldn't happen. This is because unless it shouldn't happen, can happen. Because imagine that we have a bug in the import maps and it's not able to point to the last name of the files, or we have an old portlet that was directly pointing to the name of the canonical name, the index.js, or any other case of a remote request that doesn't know the hash. In that case, we are using a strategy, another strategy, which is using TTL and etag, and that is configurable. So at the beginning, we saw that common problems and Liferay particularities, and one of them was the language labels. Traditionally, in Liferay, when you have these kind of JS files, for example, the front-end dataset index.js, these files had these labels in it. The labels for internalization were inside the file. So with this, we cannot properly cache the file because this label could be overwritten, for example, with language override. So what we have done is that we have separated in the split in build time. So now we are generating two files from that one. So for one side, we are delivering the hash file with all the business logic, and we split all the labels, and we put it in a new file called all.js in the same module that has all the labels. So the first one will be cached forever, and the second one will be with the TTL that is configurable, and it's configurable here in this new configuration in the virtual instance. So in here we can configure the TTL for the CSS and the JavaScript files, depending on your needs and depending how you deal with languages. These values can be one or another. If you are dealing with multiple and constant changes in labels, in literals, you should set a low TTL. If you don't touch that much the labels, you can set a high value. And then, as well, you can send the no cache directive for both of them. In that way, you ensure that they are always revalidated. So they are checking always if you need to download another file. So, as a summary, we have two types of files from now on. The infinite caching, all that files that are going to be hashed within the name, and the TTL or no cache that is configurable in this screen for the rest of the files, as the JavaScript labels or other that are processed at runtime. And now, demo time for Bryce.
All right, let's go in and see this in practice. So Gerardo talked about this in theory, what we did do. Now let's see what we actually have done. So this is a 2025 Q3 bundle. This will be our previous caching strategy, just to highlight where we've been. So here, let's simulate a first-time user. We're going to empty the cache and scope down just to our clay components. If we see here, we're going to see all these JavaScript files get loaded with the 200 request, and the size is going to come through. This is expected. This is the first time someone visits this page. But let's see what happens now when we reload. When we reload, we see that the status is now 304, and that means the server is telling the browser, hey, this file has not been modified. You can just use what you have in the cache. Now, the downside to this is like what Gerardo said, is that we now are still making a trip to the server. So you'll still see, even though these are cached, we still have a size that comes back. We're still hitting the server every single time. You'll also see here in our cache control headers that previously we used no cache in private, and this was because these JavaScript files had content that could change, like the language keys. So now let's take a look at what our new caching strategy is. So I have a different bundle here. This is built off of master, so it's not released yet. And we're going to do the same thing. We are going to simulate a first-time page load. And what do we notice here? We notice too, same thing, status is 200 and brings back the file size. We can look at this file. We'll notice that the cache control header changed to immutable, and then we put the max age to a year. But the big difference, like we mentioned, is that we've now added this hash to the file name itself. And this means that this hash is generated now at build time instead of runtime. So previously, on this old bundle, you'll notice that when we sent a request, there's an e tag that we sent in the header, or that the server responded with. So the server was computing this every single time there was a request on runtime to check if this is validated. Now, if we go here to the new build with our new caching strategy, these hashes are just generated at build time. So let's see what happens now with a second page visit. So this would be a second time visitor, a page request. We'll see here that it's 200, so the request is okay, but you'll notice that there's no size. That means that the browser knows, because it's immutable, the server told the browser, hey, don't worry about anything anymore. You have this resource. If you request it, don't even bother coming to revalidate it. So this is big. The browser can just always know that this is here. We see this for all of these files, that these all come from memory cache. So we can even just take a look at all these hash files that we have now. So all of our module components, or all of our module files, we have all of our Clay UI components. Everything here has been hashed because we know that these are just static build time resources. So one question is, no, we have these hashes, now what if something changes? So we're gonna simulate kind of a hotfix or a deploy of a new module. This could be if you deployed a hotfix or if you upgraded to a different version of DXP. So here I'm deploying a new version of front-end taglet Clay. This contains all of our Clay UI React components. Now, one thing you might expect is that any resource in this jar will get a new hash, but that's not actually the case. It's only going to be the updated files. So I think in this new deployment, we have 5 resources that have been changed, and it crashed. Let me restart this really quick. So this new module I deployed should have 5 or 6 Clay components that I've updated. And we can see here, even despite having the server crash, unrelated, you'll see here if we just look at the size, these are the only components that updated in that jar. The rest of these all came from the disk cache. So we only made a request for 6 files that updated. That's because it's the first time we visited the server with this new content. And if we reload again, another page visit, those are back in the cache. We can confidently say those are cached forever. Now, if you have client extensions or you have other components that are relying on import maps and pointing to, say, our Clay components, like if you have a client extension and you use, to point under import maps, you might think, oh, do I need to worry about mapping directly to this hash? Well, you don't because of import maps. So even though this hash changes, your custom code doesn't need to know what the change is. You're automatically going to get the updated files. So if you point to import Clay core or Clay dropdown, you're going to get that automatically. And that'd be the same for React and other components that we share here in DXP. So we've talked about static assets. So these are all evaluated at build time. What about dynamic resources? So those language files that we talked about. Let's reload and just search for all.js. So just to show you what these files are, these are the ones where we split out all of our language keys into a separate JavaScript file. You'll see here, we just have a bunch of translations here. And this is so that the corresponding module, in this case, it's segments experience web, can grab all those translations and make sure it's translated properly. The reason this is dynamic is because, one, we can change it in control panel, so we can override these language keys. But two, if the language changes, you'll see here that this is now totally different. So these files are dynamic in nature. So if we do a first page reload, again, we'll see it's similar, 200, size comes back. You'll notice there's no hash, so these are dynamic files. If we go to the headers, we'll see that the max age is set to 3,600 seconds. So this is about an hour. This is just the default setting we have for these files, is that every hour we tell the browser, hey, if you have this resource, if you've had it for over an hour, just go revalidate it again. But like we said, and again, these come from cache, you can configure that max age for these dynamic files. So if we go to the settings here, I'm just going to reload this. Oh, not in Arabic. Let's go back to English. So let's go ahead and just do, for these language files, let's send no cache. So we'll update. We're going to go back here. Now, currently, the browser still thinks that it can keep it for an hour. So we're not going to wait here for an hour. So let's just go ahead and simulate a full page reload, first time visitor again. We'll see here this dynamic file now has the no cache header. So that means that every time we request this page or reload this page, we're going to re-request that file. And if we go back and we change this to, say, 10, and this is seconds. So we'll go back here, simulate a first time page load. Normal request. If we reload it, let's see if this saved. Oh, this is why. Uncheck that. Set it to 10. First time page reload. Okay, expected. Let's reload it again. Okay, it's coming from the cache. But we have 10 seconds. So if we wait a few more seconds and we reload, the browser knows, hey, this is invalid. Let's go request this again. So by being able to configure this, this gives you control over how long do we want to cache our CSS dynamic resources for, or our JavaScript files, or these labels. But we do just have some defaults there for now. Now, one last thing I want to show you, and this is just in terms of performance. So let's go back to this page, and we're going to look at some Lighthouse scores. So let's start first with a clear storage. So we're going to just only look at performance, and we're going to start with a no cache when we analyze this. Oh, wait, we forgot to go to a different page. Let's go to blogs. Blogs has a lot of photos on here. So we're going to do the first run with a clear storage and see the score. 64, not great. Again, this is also a development build. But now let's see what it's like with the caches enabled. So previously we had 64, development build, no caches enabled. With our caches enabled, we now get 95. So caching helps us quite a bit here. So to kind of summarize it up for this, these dynamic files, we're going to rely on max age. We can set that. It's configurable. Anything that's done at build time, those are all static. Those are all going to be cached forever, hashed forever, and will only change if there's a change of deployment. And I will give it back to Gerardo.
Thank you, Bryce. So just to summarize some numbers, 90% of the DXP internal CSS and JavaScript files has been hashed, so they are used cache bumping, so we can rely on that. On each request that we do to the server, the transfer data regarding CSS and JS, not the images, of course, and everything, has decreased by 85% when in following visits. And as you have seen in the Core Web Vitals, the improvement is quite big. We can run the Core Web Vitals using the cache version because we know now that we are pointing to the last version of the file, so we are not seeing all experiences. And that's it. Thank you very much. And thank you to Ivan Zaera, which is one of the masterminds working on this. He is not here, but he would like to be. And that's it. Thank you very much.